Alright, this is just a little update. So you can see I've got all the magnets mounted. So the frame is pretty much done, included being balanced and adjusted. This represents where the coil is going to be. We got a pretty good clearance right there. That's probably a 1/16 of an inch away. Could probably get a little bit closer, but they all seem to be in pretty good shape. Look right here how I done this. So bent it across. This is a double stack of 144 magnets and stainless steel covers, and they're bent down on the corners. And just to put a copper strip over it, what I did is I used a caulk material to keep them from clicking. They are glued to this copper and to the cover. Cart motor, I had a few issues with these. After time, they would wobble in there and get to the point where they were clicking. So the silicone will stop that clicking. So I just wanted to give you a look at where we're at. It seems to be moving along pretty good. This is working incredibly well here. I'll give you a look at it. So it's coming along. We're ready to move on to the coils, and I had these circuit boards from a previous model, and I actually sawed them down and cut them down. They were one board. So what I did is I just cut them down. So this is pretty much my standard. It's the same design that's on the cart motor. This is an amp connector, and I used the IN007 diodes from the 1 to 3 loop, which is basically they're rated at 1 amp and 1000 volts. That little diode there could be put on the back side. You could put it on the cart motor. It jumps from that point to that point. It's jumped back here. This is an earlier way I used to do it. And once I went to 120 volts, I found I wasn't blowing as many chips. It was actually a little easier. The cart motor, I think I've only had one episode where I had an issue where I blew a chip, and that was a loose connection. So at 120 volts, it seems to work better. And we have a key here. This is set up for 12 volts. I'll replace this key with a 4.7 or 5K resistor to control the trigger on each chip. Now a lot of you are using this chip right here, which is the 2194 ML chips. John Bedini, this is one of his favorite chips, along with this little high-speed diode. The diode works good. I try for a little more torque, so I use the slower acting 007, which slams the gate just the same as this one does. It's a little slower than this diode when it shuts the door, so a little more torque. It'll run with either. You know, if you're setting them up, you could do it this way, or you can build it into the circuit board. If you're going to do experiments, this is the best way because you can change a diode when you change a chip. This is an earlier version where I was running the NE2 neons right on the chip. So the neon's tied into pin 3 and pin 2. Diode jumps from 1 to 3, and it's all built right into the chip. So when something blows, you could take it off. This required a little more soldering than I really cared to do when I was blowing chips in the early day. So I pretty much have completely discarded the NE2 neon 120 volt lights. They didn't save the chip as much as I would like, and they just got to be a nuisance. And because I have capacitors on the output, it hits the capacitor. So if anything happens, it'll ramp up the voltage in the capacitor if it's not connected to the battery. And all that stuff in my design, it's pretty much hardwired. It uses relays to switch this stuff. So I don't really have to worry about that. And by having a large capacitors on the output, I can switch it live. I can switch the battery banks with a relay pack, and the excess energy is just flowing into the capacitors. It's switched after the capacitor. Early design, John Bedini's favorite chip, and the circuits. So I've cut all the pieces. So the next step is the coils, and the coils are going to be on the free version. This is what it'll be, and that'll be mounted, like you can see there, up in between the frame. I'm going to use the transformer plates, just like in the other design. This is an early one that I used. My N52s are 1 inch square. I will be using smaller and wider transformer plate. What it'll be is a hair over 1 inch, maybe a third larger, so a little taller, so the magnetic field extends beyond the edge of both chips, because if you got a little slop in the shaft, it might float a little bit left and right, and I just want to make sure that I stay inside the field. So I'll make this 1 1/4 inches and make it a little wider, and then these are going to get repurposed for this design. So that's kind of where we're at. It's what's got done this week. I'll keep giving you these updates and you'll see this thing running. I've put over 60 video clips on the Avid system to edit, so I'm really starting to back up with this video, but I'm trying to get this done. So I'm shooting it, ensuring that I have what I need to edit, and then the free videos will be edited at the same time I'm going to release the Boxmotor, the full home edition power plant. So this is obviously the small version. If you've seen the other videos, you know the big one's 4 foot square. I'm working any details out, designing it on a computer in 3D, and ensuring your parts and stuff work together properly is one thing. You don't know what you get until you've actually built one. I have to build it to ensure that I haven't missed something. That's kind of where we're at. Look for these updates, and within 2 or 3 weeks, look for the new videos to start coming online. This is Technomancer for 0 Point Fuel signing out.